Okay, hello everyone. Good afternoon. After we discussing about the Bernoulli equations for the first order ODE, there are uh, another methods to solve the ODE is exact equation equations. Okay, we will discuss the exact equation today. Okay. So we consider the following standard form of ODE. So we considering this standard form of ODE, pxy dx plus key x comma y dy is equal to 0. So if dou p per dou y equivalent to dou q per dou x, so the ODE is exact. This means that the functions, the function of u x comma y is exists such that the u is equivalent to the u per the x dx plus the u per the y dy. So it's equivalent. This is the equivalent to the u per the x is equivalent to p. So this is a p dx plus q dy is equivalent to 0. So we have to solve the u per the x is equivalent to p, and the u per the y is equivalent to q to find u x comma y. Okay, then we can see that du here is 0, so then du is equivalent to 0. It gives u x comma y is become the constant, and c is the constant. Okay, so these equations give the general solutions. So these last equations give the general solutions of p dx plus p dy is equal to 0, as we informed for the first time. Okay, so in exact equations, the first we have to check whether dou p per dou y is equal to dou q per dou x. If this similar, so ODE is exact, so we can use this method to solve the ODE. Okay, so this is the procedure how to solve the exact equation in ODE, and I give you one example in this video. Okay, so this is the exercise 1 per x dy minus y per x quadrats dx is equivalent to 0. So how to solve this equation? The first we have to compare it with the standard form. The standard form in above, we say that px comma y dx plus key x comma y dy is equivalent to 0. So this is the general form. Okay, so this is the general form. And then from this one we can see that this is the p. Okay, this is the p, and this is the key. Okay, because this is a dy, so dy is refers to key, and this is dx. Dx is refers to p. So we can see that we can write like this one: px comma y is equivalent to, the p is minus y per x quadrats, and then the key x comma y is this one, this constant here, 1 over x. And then we remember that to determine whether this equation is exact or not, we have to check dou p per dou y is equivalent to dou q per dou x. Okay, so dou p per, so we have to check dou p per dou y. So this one is dou, this is the px comma y. So we make a differentiation, partial differentiation, dou p per dou y. So we can get that dou p per dou y is equivalent to make this differentiation over y. So y become 1. So we can get that this one become 1 per x quadrats. Okay. So it must be dou q per dou x. Yeah. So this one, if you make a differential of this one, you get the similar differential value here. Okay, so the ODE is exact. Okay, since this exact, so the equations exist of u x comma y is exist such that we can this one. So the du is equivalent to dou u per dou x dx plus dou u per dou y dy. So this is a p dx plus q dy. So this is must be equivalent to 0, and the solution has the solution. So this is the solution, has a solution of u is equivalent to c, and this is the c is the constant. Okay, so solution to these equations. So the first we have to du per dou u per dou x is equivalent to p. So it gives, I said before, this one, the p here, yeah, the p here is y per, so dou y per dou x equivalent p, and so dou u per dou x is minus y per x quadrats. And then the second, dou u per dou y is equivalent to key, then the key is 1 per x, so dou u per dou y is equivalent to 1 over x. Okay, so we make integrations, the partial integration of this one. We make this one, we call this is the I, and this is the I2 here. So we make a partial integrate this one. We make integration of this one. So we have to integrate I respect to x. So we make the integration here. Okay, respect to x. So we get that u become y per x plus theta plus constant, like this one. I write theta y. Okay, and so this one theta y is an arbitrary function of y. And then if we make a differentiate with respect to y, so we make a differentiate respect to y, dou u per dou y is equivalent to 1 per x plus dou theta per dou y. Okay, so we make a differentiate of this one respect to y. So this is the equivalent to, okay, yeah, 1 per x plus dou theta per dou y. And then if we compare to the equation number 2 here, the equation number 2, dou u per dou y is 1 over x. So we compare with 2. Okay. So we compare this equation the 2. 1 per x plus dou theta per dou y is equivalent to 1 per x. 1 over x is equivalent to, here is equation 2. So we get that dou theta per dou y is equivalent to 0. So the theta is c accents here, and c accent is the constant. And u become so we make integration. This is the u. This is the u, right? This is the du per du per dy. So to get the u, we make integration of this one, so we can get that u become y per x plus c accent. Okay. Okay. Because of the u is 0, so implies u becomes c, and the c is the constant. So y per x is a, and a is c minus c accent. This is the constant. So like this one. So this is the du is equal to 0. So implies that this one u, because the u is 0, so we can make integration. So u is c, is the constant. Okay, so we replace this one. So yeah, c okay, c is y per x plus c accent. So we replace cx, y per x become a, and the a is c minus c accent. So this is the solution of these exact equations. I think enough for this one exact equations exercise and the example. Thank you and bye bye.